Okay, so let's look at a couple further details regarding a histogram. And I need now to explain what that optional red broken line that we drew on top of each histogram bars, and altogether it's gonna how it explains the graph. And then of course we will keep looking further and more into more details about that. So here's the thing. So this is the histogram we built for data 1 right here. And this data is small, so the line is pretty broken. But then right now, this is how I see it within our histogram for data 1. So right here in our histogram of data 1 right here, if we can simply disregard the bars inside of the broken line in red right here. So allow me to do this. I'm gonna informally erase all of the bars because I want to put everyone into that situation where a lot of times we don't have time to look in details. We don't have time to look in details into every single detail about how each bar is. So in that case, when we cannot pay too much attention to the bars, then immediately the broken line here is going to tell us, or it's going to give us some impression. It now gives me an impression about, as a histogram, as a whole data together, it gives me an impression that, hey, data 1 here is having more focus, of data in a lower values. And then when it comes to those data values that are being higher than the data in our data 1 here, the histogram is showing we're having less concentration due to the little amount like that. And so that's the meaning of the broken line. But sadly, again, since our data 1 is so small, the broken line is quite broken. The idea now is that, think about one day when the data you're working with is so big. It could be that you're working for the government on data about annual incomes for every family in the nation. And so when the data that you're working with becomes that big, then generally, and it will come, the broken line in red will become a nice, smooth curve. The reason it becomes a nice smooth curve is because there could be a lot of bars, and each bar is now in a much bigger setting. Each bar becomes a small, tiny width histogram bars. And like I explained again, when there are that many bars like there, nobody's going to be looking specifically into each bar anymore, but instead they're looking at the entire structure, the entire look of the histogram. And so now as we're looking specifically into just the kind of shape, the overall shape that this line creates, this curve, this red curve creates, it gives us now the term here we're going to start using a lot later on, but it's an early introduction. But the shape here, we refer to that as a distribution It's a distribution shape. So your histogram in general, once you're looking at through all bars inside of that, then these are creating this line, this curve through the tips of all the bars, creating an overall distribution shape, so that people, when they're looking at your histogram, they can immediately tell where your histogram, where your data focus in terms of the value, and where your data having less focus, and all that. And it also shows up and down in terms of, the more or less data being in that area. And so once again, keep in mind, so see, I was saying earlier that it's always a good idea to shade your data. So imagine now that inside of your data, inside of your distribution curve, distribution shape right here, and all that shading part, no, they are all, it represents the amount of data, all the data. The curve is not, the curve here might extend even infinitely further out, but no matter how far that covers all your data. So it's a little early to preview this to see this, but a lot of time I call this is 100% of all data, no matter how far it extends. But all that shaded data inside of your distribution shape is 100% of all data. And so now, in that way that we start getting into distribution shape. And so I'm gonna show you a few variation, a few different various shapes that commonly happens out there. So as far as distribution shapes, so there will be times that, and it already happened right in your data one. So sometimes now pretending that you're working with a gigantic data, then sometimes your histogram, after constructing a lot of histogram columns and a lot of histogram bars right here, and your distribution shape turns out something like this. And so how I see that now is that this data, and once again, low values, high value to the right hand side. And so the way we're looking at numbers is always those histogram bars, those intervals going from low to high, from the left to the right, as we always know. And so at this point right here, this histogram, just simply looking at the line, the curve, the nice smooth curve that describes the distribution shape, it does tell me that the data here has a higher focus in terms of the amount of data, focus more into the lower side. And then as it gets to the higher values right here, we're having less data, and you can see that the tail is getting fading out and extending to the right hand side. And so a distribution shape like this, we actually have a name for that. We refer to this as a skewed right distribution. And so now if we can have a skewed right, the main, like I said, what to quickly recognize that skewed right distribution is where we have a big focus on the left hand side, big focus area of data to the lower side, to the left hand side, and the long tail extends to the right hand side, indicating fading away in terms of the amount of data. So in that way, there could be another time that when you work with your data, in another data with a histogram, your histogram could be showing a shape like this. And once again, same rule of thumb, low values, low intervals, low histogram classes to the left, and getting higher to the right hand side. But sometimes your histogram bar gives a shape that looks like this. So looking at this histogram bar, what immediately catches my attention, and also anyone else looking at your histogram, it will catch their attention that this histogram, this distribution shape right here, has more data focused to the higher value on the right hand side, and then data is becoming less focused as we are looking further back into the left hand side or the lower value side right here. And so in that way, you can now start making a wild guess, and your guess is correct. We're going to refer to this shape right here as a skewed. It's a skewed left. The long tail extends to the left, and that's why it's called skewed left. The skewed left distribution. Okay, and then let's briefly look over skewed left. So I starting out showing you skewed right distribution, and that's actually something similar to our histogram that happened in our example for data 1. And then skewed right, just now I show you that in some time it might happen. But either skewed left or skewed right, they all belong to a one family of These two are belong to one family that I generally regard to, and that's not only my term. Everybody is using this term out there. But these two shapes are in a bigger family that we call, they are the skewed distribution. So the shape that's having a long tail extend to one side is called a skewed distribution. And then outside of the skewed distribution, there will be time. It didn't happen in our lecture so far yet, but there will be time that your data, after constructed a histogram, your data gives you a histogram that has a shape like this. A shape where it might peaks up somewhere and peaks down and has another one. So it doesn't have to be perfectly, it doesn't have to be exactly perfectly. But what catches my attention in a histogram shape like this, in a distribution shape like this, is that you have a sense simply by judging, relying on your own eyes right here. You can simply tell that there's a clear, recognizable enough center where the two sides, and once again to remind everybody, data are being located completely inside of your line like that, inside of your nice smooth curve. And so this is the area where all data are being inside. So I can kind of recognize that there's a clear center right in the middle where they're about the two sides are perfectly symmetric from each other. And now I just said that term. A distribution shape like this, people commonly refer to this as a symmetric distribution. You can recognize a one clear center, and data are about to be equally divided on the two sides of that nice center distribution. Okay, so it's a symmetric distribution. And so now under that, and so you can see that symmetric distribution is a big family of all those kind of distributions that having the data being equally divided on the two sides of a clear center. And so specifically getting into all the symmetric distributions, there's one family, there's one particular shape that eventually somewhere in the middle of the quarter we will start turning all of our focus into that shape here. So like I'm saying, I'm about to introduce a subfamily of all the symmetric distribution. But so here's your histogram, and at this point I'm starting to get a little lazy in terms of always drawing the vertical line. So there's always a vertical line indicating the frequency of your histograms. But there will be one day we're gonna be working with a distribution shape where it's a symmetric distribution, because we do have a nice, clear, I wouldn't say exact, but almost perfectly equally divided. And on the two sides here, things are equally fading away. And so that symmetric distribution in particular, we have a very special name for that, and we're going to refer to this as a normal distribution. So this particular symmetric distribution, we have a special name for that. It's called a normal distribution. And what to recognize about a normal distribution is, you're looking at the shape in general, it does form a bell curve shape. The shape itself, the shape of the curve itself, looking like a bell picture. And then that's all how it happens. So the center is right here. That's clearly that symmetric center is clearly dividing the entire histogram into two equal area, and they all fading equally away on both sides. And that's all. And so there are, outside of these forms right here, Well, the good news is that the normal distribution is the one that happens most commonly. And we actually will learn technique to, I would use my term that we're going to use technique to force data later on, to learn technique to force data to become a bell curve data. Because like I said, it's the one that happens most commonly. And that's the good news. Skewed left, skewed right does happen in your work, but not as commonly seen as this bell curve shape data, as this normal distribution data.